He's here and will be on the panel. Bob will be live. Doug is remote, and he will be pre-recorded. And then Brian's not here, but we get his presentation because he did that for us in advance. Okay, so I'm the first speaker, so we'll start with me next. Great, so I'm going to talk about an open source device to facilitate mobile fishers' real-time awareness of deployed on-demand fixed gear. And I did this work with Jim Partan and Dennis Guy at Hui. And I want to thank our funders at Pew Charitable Trust. Next. Okay, so mobile fishers drag nets or dredges near the sea floor. Fixed fishers set trawls. You all know this. To avoid gear conflict, mobile fishers need to know where the fixed gear is set on the seafloor. So you can imagine a conversation between a fixed and a mobile fisher. I've extracted all the expletives that might be used in such a conversation. Next. So the concept for this to provide mobile fishers gear locations is really simple. You have, and I borrowed some cartoons from the Fontes documents. This is a mobile fishing vessel that wants to know where gear is nearby. So a device in his wheelhouse goes up to the cloud, says, what gear is nearby? Next. And then the cloud responds and said, here's all the positions that are nearby. And then that device feeds the gear locations next to the chart plotter. Simple, right? Okay, so we built this. Thank you. A very simple system, and it's actually running over here if you want to see it up close. It's not that exciting, but it's there if you want to stare at it for a little while. It's sort of in simulation mode. It starts, again, this is sort of Fontes nomenclature. We called it the black box originally because the central command unit, which is just a computer, wasn't designed to have any interface. So it just sits on a mobile fisherman's wheelhouse in the wheelhouse and just runs. And the mobile fisherman does nothing to it other than turn it on at the beginning of the voyage. So we're using a Linux computer, a Raspberry Pi, and then next we go to have attached to it a little GPS puck, in this case a US GlobalSat. It assumes that Raspberry Pi can get to the internet via an at-sea real-time internet connection through whichever you like, Iridium Certus, Starlink, or coming soon, Project Kuiper. And then for a chart plotter, we're using OpenCPN, which is an open source chart plotting software. And then next, the cloud. Next, we're going to use EarthRanger. For this application, though, since we don't have on-demand NMEA messages for chart plotters worked out, and I'm really excited to hear Doug's talk shortly about where we're at with that. That's NMEA is just this communication system between marine devices. Since the central command, we don't have that communication worked out, I'm going to put the chart plotting software directly on the Linux computer. And so the Linux computer, the Raspberry Pi is just running Python software to do all the functionality, and then it's also running OpenCPN at the same time to display the gear location marking information. And I want to give a huge thank you to Colin Vincent at Ropeless Systems for sharing their Ropeless plugin for OpenCPN. That was a huge help to us and probably saved the project. So thank you, Colin. Next. Okay, this is it. It's not very exciting. It's an external monitor with plugged into a Raspberry Pi and a GPS plugged into the Raspberry Pi. Here's all the stuff, and you can see the cost. It's about a little over $300. I could probably get that down by another 40 or 50 bucks because I've completely overspecified the Raspberry Pi. But anyway, it's not that expensive. Next. So this is just a zoom in on the screen. So every few minutes, the Raspberry Pi takes the GPS position from the puck, goes up to EarthRanger, says, is there any gear around me? EarthRanger responds with a message. The Python program passes that gear location information off to OpenCPN, and OpenCPN displays it. The green dots are singles, the green dots with X's and a line are trawls, and this just as the ship goes along, every few minutes this gets updated, and that's how a mobile fisherman would see on-demand gear. Next. This is another version of it, not another version of software, but another version of the hardware. In this case, it's a small 10-inch touch screen. in a ruggedized case, this is something, if this thing's going to get knocked around in a wheelhouse, you would want something like this. But the same thing, and now we're down to $270. And again, we could probably drop that by another 30 or 40 bucks. Great. Next. So we're done with this. The development's completed. Next. 3 systems have been assembled. Next. And I've given it off to the Northeast Fishery Science Center folks for their trial work. Next. And I'm waiting to hear back how the fishermen and Northeast Fishery Science Center folks, how it worked for them. That's it. Thank you. Okay,